So this is going to be our proof of the alternate interior angles theorem. Given that L is parallel to M, so I've got two parallel lines, prove that 1 and 3 are the same. I'm sorry, 1 and 2. Statements and reasons. I always start with my given. Now there's another rule on all of this where things start to get a little bit confusing. And that is you cannot use the theorem you're trying to prove. So you can't say 1 is congruent to 2 by alternate interior angles. It's not allowed. But you can use some of the other theorems or postulates we've talked about both in this chapter and in previous chapters. Reasons or justifications. So if I've got two lines that are parallel, in the most recent memory, what are some things I know about them? Okay, by definition, they don't intersect. What else? Gotta be coplanar, also by definition. How about recent theorems? Or postulates? Or theorems that are really postulates? Corresponding angles are congruent. Do you see any corresponding angles marked off up there? 1 and 3. So according to this postulate, they call a theorem, but it's really a postulate. Angle 1 is congruent to angle 3. Corresponding angles. Postulate theorem, depending on who you talk to. Corresponding angles are angles that share the same relative position. Oh, that's the squiggle that didn't quite come through. There we go. Now, the one thing I want to mention before we get too far going along, this idea that lines are parallel, that block of theorems we started with today are all the places you can go from there. The only one we can't use for sure is when we're trying to prove. This is the most common one we're going to fall onto, corresponding angles postulate theorem. Because it's, if you don't know what else to do, but you know the lines are parallel, throw that out there. Oh, all right. So the next step down, you want to talk about angle 2 is congruent to angle 3 because they're vertical angles. Well, you start your given, and then you just ask yourself, what do I know from that? Or you look for some hints. For example, I just talked about 1 and 3. And I know I've got to try to connect 2 and 3, or 1 and 2. But what do I know about 3? Well, vertical angles. Why would I do that? Why? You know it. If I said that 1 is 3, it goes with 3, and 2 goes to 3. Yeah, you just went the next step, and you finished the proof all in one shot. By the transitive properties, like you said. Property of, and this is of congruence, because we're talking about congruent things. And that's what I wanted to prove, right?
Can we use PFC?
Sure. The thing about all of these is that they almost all start at lines being parallel. And while you can talk about the definition of parallel, that's a good thing to know, it doesn't come up often in proofs. What comes up a lot more are these initial theorems, postulates, like the corresponding angles postulate, the alternate exteriors, or and you can use them if you're not proving it, alternate interiors, and same-side interiors.